Good day everyone. Last time we have discussed the basic building blocks of C, such as the prepossessor directives, function statements, as well as the comments that are being ignored by the compiler, but we add in order to improve the readability of the code. So we have also discussed variables and the different data types, such as integers, floating point, character, and Boolean types. Lastly, we have shown how to print and display string of characters as well as results of computations. So computations such as computing the area of the rectangle, calculating for the value of a polynomial equation given x, for example. So from this, you have experience dealing with mathematical operations using basic operators that are being provided in C. So today, we will discuss more about constants as well as the operators that are fundamental to C programming. Before starting our discussion, do you remember this block of code that we have discussed last time? So this is a block of code that computes for the area of a rectangle. So however, we did mention that while there are no syntax errors in the code, there are magic numbers that are not clearly defined. So for example, the numbers 5 and 10, we do not know which one is the length and which one is the width. So their meanings may not be at all clear to someone reading the program later, even for us who wrote this code ourselves. So when a program contains constants, it's often a good idea to give them names. So formally, constants refer to fixed values that the program may not alter during its execution. So these fixed values are also called literals, and it may belong to any of the data type that we have discussed before, such as integer, character, float, or double. So, again, it can be of any of the basic na data types, integer, floating point, character, constant, or string, literal, or it could be an enumeration constant that we will discuss on the latter parts of our discussion. Okay, so let's start with the integer na constant. So an integer constant must have at least one digit, and it must not have a decimal point. So it can either be positive or negative. So negative 1, 1, 0, negative 15, etc. are valid. Also, no commas or blanks are allowed within an integer constant. So for example, you would like to define an integer constant 1000. You cannot add a comma between 1 and the next 3 zeros. So yes. And if no sign precedes an integer constant, it is assumed to be positive. And the allowable range for integer constant is negative 32,768 to 32,767, unless you add modifiers that alters the size of the integer. So we have discussed that last time. Okay, so here are these are some other examples of integer constants. 85 can be a valid na number, and can be a valid na integer constant. And if we want a number on the octal base, we precede it with a 0. And for hexadecimals, we precede it with 0x. And we can also add U if we want to indicate that it is unsigned. So if you remember from our last discussion, unsigned is an example of a modifier that alters the meaning of a variable. So adding unsigned, we are specifying that a variable can only hold positive numbers. So we can also add L to specify that it is a long integer. So meaning, if you remember from our discussion again, long is an example of a modifier that alters the size of alters the size of a specific variable. So for example, for integer, since we have specified that it is long, so we are increasing the capacity. So we can also add UL for unsigned na long. So these all are valid na integer na constants. We can also specify a floating point constant such as double or float. So it must have at least one digit. So 0.3, 3 point, or 0.3 are valid, but not only point. So that will cause an error in your program. So it can also be either positive or negative, and similarly, if no sign precedes a floating point na constant, it is assumed to be positive. And also, no commas or blanks are allowed within a real na constant. So, real is also synonymous to floating point na constants. In other programming languages, or other programmers prefer to call it real or rather than floating point. Okay. So here is you can represent floating point literals either in decimal form or exponential form. So a floating point literal then has an integer part, a decimal point, or if you are using an exponential form, it has either a fractional part or the exponent part. Okay, so while representing using decimal form, you must include the decimal point, the exponent, or both. So for example, this 3.14, which is a value for pi, is valid, and 314,159 raised to negative 5 is also legal. So we have included here the exponent, right? So, and then, or you could include either a decimal point or the exponent or both. So this is an example. So here are examples of illegal na floating point na constant. So 510e, so you did not include the exponent. And then 210f, you do not have decimal or exponent. And then point, point e 55, so there's a missing integer. Or we also have character constants. So a character constant is a single alphabet, a single digit, or a single special symbol enclosed within single quotes. So the maximum length of a character constant is one character. So here are examples. You can, as you can see, you enclose a single alphabet X in a single quote, and these are also valid. 0, you enclose it in 0. It is not understood as an integer but rather as a character. And you can also enclose a symbol. Okay, so string constants are enclosed within double quotes, and it contains characters that are similar to character literals. So it can contain plain characters or escape sequences, and you can also break a long line into multiple lines using string literals and separating them using white spaces. Okay, so here are some more examples. You can check this later. This will be helpful when you deal with a lot more different data types. And if you want to print, let's say, for example, a long int, so you can refer to this one. So since it also includes here the placeholders, kumbaga, on how you can display and display such data types. Okay, so there are two ways by which you can define constants. So you can use a feature known as a macro definition using a define na prepossessor, and you can also use a const na keyword. So we will discuss each on the preceding slides. Okay. So do you remember our C program last time to compute the area of a rectangle? So just a brief recap, we have first declared the variables length, width, and area as data type na integer. And then we have assigned values to our length and width, and we computed the area and stored it in a variable area that we have declared. So later on, we have printed out the area of a rectangle with length equals 5 and width equals 10 is equal to 50. So let's rewrite the code such that we are setting the length and the width as constant. So define is a preprocessing directive just as include is. So there is no semicolon at the end of the line. So when a program is compiled, the preprocessor replaces each macro by the value it represents. So for example, this constant na length is being replaced by its value, which is 5. Same for width with a value of 10 and the new line with which is an escape sequence \n. Okay. Alternatively, you can use the const prefix to declare constant with a specific type as follows. So normally we just declare variables with the identifier and its data type. So we just add the const keyword before the type to indicate that it's a constant. For example, for the length and the width, we have before we specify that it's an int as well as a const. But for the new line, since it's a character, we declare it as const char new line equals the escape sequence \n. Okay, so notice that we have used only uppercase letters or capitals. So this is a convention that most C programmers follow, but not a requirement of the language. Still, C programmers have been doing this for decades, so you wouldn't want to be the first one to deviate. So it's a good programming practice to define constants in capitals. Okay, so now that we are done discussing what constants are, so we can proceed to our next topic. But before that, let's have a quick recap. Okay, so one of C's distinguishing characteristics is its emphasis on expressions or formulas that show how to compute a value rather than statements. So the simplest na expressions are just variables and constants. So in this code, what are the variables that we have used? So yes, we have used x, x2, x3, x4, and x5. Okay, or as well as the result, which stores the final result of the expression. Okay, so these variables represent a value that to be computed as the program runs. So for the lines 10 to 15, and this one, x2 equals x times x, x3 equals x times x times x, we are computing for the values of x squared, x cubed, x raised to 4, and x raised to 5 simply by multiplying the x by itself. So these are essentially example of expressions by which we apply the multiplication error to operands x. Okay. So this is what we are going to discuss next. Operators, which are the basic building tools for expressions. Okay. Operators are basic tools for building expressions, as I have just said, and C has an unusually rich collection of them. So as discussed, you could use an operator to compute or retrieve a value or change the value of an object. So operators in C are used to perform logical and mathematical operations. So joining these operators with variables and constants form expressions. So, but what are expressions? So expressions can be used to compute a value, write conditions, as well as perform comparisons. So simply said, an expression is composed of operators and operands as well as variables, and expressions can also be nested. So for example, in this parenthesis a plus b times c. So the operator here is the multiplication operator, and the operands will be the a plus b, which is grouped using a parenthesis, and c. So a plus b is another na expression that is nested on the expression a plus b times c. So a plus b parenthesis is also another na expression, but simpler. So the operator here will be the parenthesis, which essentially just groups your operands your operand a plus b. Lastly, the a plus b, the operator is the plus na operator or the addition operator, and the operands will be a and b. So finally, a and individually a and b are as variables are also expressions. So let's get to know more about the other operators in C. So C provides rudimentary operators which are found in most programming languages. Arithmetic operators such as addition, subtraction, multiplication, and division. And then we also have the assignment operators that allows us to assign a value to a variable. And we also have the increment or decrement operators. You will know about that later. And we have the relational operators to perform comparisons. And we also have the logical operators to help us build conditions. And lastly, we have the conditional operators. Okay. So let's start. The arithmetic operators are operators that perform addition, subtraction, multiplication, and division. So these are the workhorses of many programming languages, including C. So an arithmetic operator can either be unary or binary. So when we say unary, we only require one operand. So an example is plus or minus, or which simply indicates whether a number is positive or negative. So the unary operator plus usually does nothing actually. So without this, the number will simply be interpreted as a positive na integer. While when we use a unary na minus, we indicate that that a number is negative. Okay, so the binary na operator on the other hand require two operands. So of course, these operators already look familiar to you. So you have already learned that these operators, addition, subtraction, multiplication, and then the division operators are used to perform basic mathematical operations. So the percent, on the other hand, is an operator that you have already encountered during your Python programming class. So essentially, this operator is simply used to compute for the remainder when we divide two numbers. For example, in here, we add 3 and 4 by using the addition operator and store it to variable a. So what will be the value of a now? So it will be 7, right? So as mentioned, an expression can contain mixed variables and constants. So in B, we are mixing variable A and a constant 2. So we are adding A and 2. So previously the A is 7. So 7 plus 2 is now 9. So now for C, we are computing for the remainder of b when it is being divided by 2. So 7 divided by 2 is 3, and we have a remainder which is 1. So the value of c will be equal to 1. Okay, so these binary operators, except the remainder operator, allow either integer or floating point operands, and you can mix both. You can mix either integer and floating point. For example, we want to add 2 plus 2.5. So the result will essentially be 4.5, which is a float. Okay, so let's move. However, there are some things that we have to remember. The division and remainder operators require special care. So the division operator can produce surprising results. So when both of the operands are integers, the result is truncated, dropping the fractional part. So for instance, when we divide 1/2, the result will be 0 and not 0.5. So the percent na operator also requires integer na operands. So if either na operands are if either operand is not an integer, so the program will not compile. So also the zero as the right operand of either division or the remainder na operator causes undefined behavior. So there might not be error during the compilation, but the program could stop abruptly or could produce any garbage value during execution. Okay, so now let us proceed to the operator precedence and associativity. So when an expression contains more than one operator, its interpretation may not be immediately clear. For example, um, uh, when we compute I plus j times k, do we mean to add I plus j, then multiply the result by k, or multiply j and k and then add I, following the MDAS rule in math? So, one solution to this problem is to add parentheses, writing either I plus j parenthesis times k or I plus parenthesis j times k. So as a general rule, C allows the use of parentheses for grouping in all expressions. So what if we don't what if we don't use parentheses? So what will happen? So will the compiler interpret I plus j times k as I plus j parenthesis times k, or I plus parenthesis j plus k times k? So C uses operator na precedence rules to resolve this potential na ambiguity. So the operators have the following precedence. So the unary na operators, the plus and the minus, the unary plus and minus have the highest na precedence, followed by the multiplication operator, the division, and the remainder na operator. So we note that these operators that are on the same line have equal na precedence. So anyway, after the multiplication, your division, and your remainder on the operator, we have the binary plus or minus, or the addition and the subtraction operators. Okay, so when two or more operators appear on the same expression, and we can determine how the compiler will interpret the expression by repeatedly putting parentheses around sub-expressions, starting with the high precedence na operators and working down to low precedence na operators. So let's illustrate it with the following examples. So in the expression I plus j times k, we know that the multiplication na operator has higher precedence than the plus na operator or the addition operator. So we group j times k using parentheses, which essentially tells the compiler to evaluate it first before adding it to I. Now, for the next example, we know that the unary operators have the highest na precedence, so we add parentheses to negative I and negative j first before negative I and negative j. Okay, so meaning this negative will apply to the number first before we multiply the two numbers. Okay, so lastly, we have the plus I plus positive I plus j divided by k. So we know that
the unary operators have the highest precedence, so we group positive I first, and the division operator has higher precedence than your addition operator, so we group J divided by K first. The operator precedence rules aren't enough when an expression contains two or more operators at the same level of precedence. So in this situation, the associativity of the operators come into play. So the binary operators are all left associative. So we group from left to right. So for example, we have the I minus J minus K. So we group I minus J first, and then for the I times J divided by K. So we know that the operators multiplication and division have the same precedence, so we group from left to right. So we have to evaluate I times J first, then it will be grouped with divided by K. So meanwhile, the unary operators are right associative, and it groups from right to left. So example, we have the negative plus I. So we are grouping from right to left, so we group plus I first. Yes. Okay. So there are a lot of operators in C that few programmers don't bother to compute the precedence and associativity rules. So instead, they consult table of operators when in doubt, or just use plenty of parentheses in order to make sure that there are no ambiguous statements that are being encoded in your programs. Okay, so let's have an example. So our first example is computing a barcode digit, a check digit. So a barcode represents a 12-digit number. So for example, we have the digits 0, 13, 800, 15, 173, and 5 appearing underneath the barcode. So the first digit here, for example, the 0 in the given example, it identifies the type of the item. So it's 0 or 7 for most items, and it is 2 if the item must be weighed, and 3 if it's a drug and health related merchandise, and 5 if it is a coupon. So the first group of digits, on the other hand, which in our example it's 13800, it identifies the manufacturer. And the second group of 5 digits, or the 15173 in our example, identifies the product, including the package size. So lastly, we have the final digit, or what we call as the check digit, which identifies error in the preceding digits. Okay, so if the barcode is scanned incorrectly, the first 11 digits probably won't be consistent with the last one digit. So, and the store's scanner will reject the entire code. So the method of computing the check digit is first we sum the first, third, fifth, seventh, ninth, and 11th digit, and we have the second sum, which adds the second, fourth, sixth, eighth, and 10th digit, and then the result of this sum one first, third, fifth, seventh, ninth, and 11th will be multiplied by 3 and then added to sum 2. And next, we will be subtracting 1 from the total, and then we compute remainder when the adjusted total is divided by 10, and lastly, we will be subtracting remainder from. So here's an example on how we can compute the barcode check digit given 0, 13800, 15173, and the check digit 5 as an example. So we add the first, third, fifth, seventh, ninth, and 11th digits. So these are 0, 3, 0, 1, 1, and 3 in the corresponding example. which is equal to 8. And we have for the sum 2, we are adding 2nd, 4th, 6th, 8th, and 10th na digits, which correspond to 1, 8, 0, 5, 7 in the given example. And then we compute for the total, which is simply done by multiplying the sum 1, which is 8, by 3, and then added to sum 2, which is 21. So 24 plus 21 is 45, and then we subtract 1 from the total. So 45 minus 1 will be equal to 44, and then we compute the remainder when the adjusted total is divided by 10. So the remainder is 4. And lastly, we subtract the remainder from 9. So, which gives us a check digit, which is 5. Okay, so, for instance, we have these barcodes for the Jif Creamy Peanut Butter. So, and then also Ocean Spray Jellied Cranberry Sauce. So, they each have a different barcode. So, let's write a program that calculates the check digit of a barcode. So here's what a session with the program will look like. So we have three groups. We first let the user enter the first digit, and then the first group of 5 digits, and then the second group of 5 digits. Okay, so after the user will enter the first these three, your program will show the computed check na digit. Okay, so instead of reading each digit group as a 5 na digit number, we'll read it as a 1-digit number. So reading the numbers as single digits is more convenient, and also we won't have to worry that one of the 5-digit numbers is too large to store in an int na variable. So some older na compilers limit the maximum value of an int to 32,767. So to read single digits, we'll use scanf with a percent 1D conversion specification, which matches only 1 digit na integer. Okay, so here's the code. So we will first, of course, do not forget your preprocessor directive stdio.h. Otherwise, we won't be able to display or write any string to our computer. So then we will be declaring our variables. So we first declare d as our first digit, and then we have I1 to I5, so to represent the first group of 5 digits, and J1 to J5 to represent the second group of digits. And also we are declaring additional variables for the first na sum, the second na sum, as well as the total. So as specified earlier, we will ask the user first to on line 11. Okay, we first ask the user to enter the first na single digit, and then we scan the digits. So we include here %1d because we want to specify only 1 digit na integer, and then we use a %d simply just to point to the address of d. And then we let the user enter the first group of 5 digits. So we can do this by simply specifying 5 like placeholders for each of your values, and then storing it in their corresponding addresses of each variable, address of I1, I2 up to I5, and similarly we do the same for J1 to J5, and then we just follow the procedure. We add the first, third, 5th, 7th, 9th, and 11th digits, and then for the second sum, the second, 4th, 6th, 8th, and 10th digits. This is in line 21. And then for the total, we multiply the sum 1 by 3. So 3 times the first na sum and added to the second na sum. And lastly, we will be subtracting 1 from the total and compute the remainder when the adjusted total is divided by 10, and we subtract the remainder from 9. So that will be your check digit. Okay, so do you have any suggestions on how we can improve the readability of the code? So anyway, you can just message me that later. Okay, so now we have the assignment na operators. Okay, we are done with the arithmetic. It's very easy, right? So anyway, let's move on. So um, what's the simple assignment na operator? So once the value of an expression is computed, we'll often need to store it in a variable for later use. So for example, before we have computed for the length and the width, and we stored it in your variable area. So the idea is the same. So we are assigning that the value of the area will be the result of computing length and the width. Okay. So here's the basic na syntax. So V equals E. So of course it should be followed by your semicolon. No. So we first evaluate the expression E and then copy its value to V. So your E can either be a constant, a variable, or a more complicated na expression. So for example, 5 is a constant that is being stored in your variable I, and your variable I is being, the value of I is now being copied to the variable J. So J will now be equal to I. So we can have more complicated expression like 10 times I plus J, which is being stored to your K. Okay. Okay. So in many programming languages, assignment is a statement. In C, assignment is just an operator like your addition operator. So in other words, the act of assignment produces a result, just as adding two numbers produces a result. So the value of an assignment V equals 3 is the value of V after the assignment. So thus, for example, let's say we have declared a variable, declared an integer I and a variable f with a type float. So when we have assigned 72.99 f, which is a float, to an integer I will now be 72. So there is a side effect. So since we have declared I as an integer, it cannot hold numbers which has decimal na points. So in other words, it is being changed into an integer, and your f is declared as a float na variable. So we have assigned a value 136 to your f. 136 is an integer, but since f is a float, your value of your f now is 136.0. Okay, we have an error here because we do not have a semicolon, so you just note that later. Okay. Okay, so since the assignment operator, since assignment is an operator, several assignments can be chained together. So the operator is right associative, which means we are grouping from left to right. So this assignment I equals j equals k equals 0, semicolon. So since the equals operator is right associative, we first group from k equal to 0, then j equals parenthesis k equal to 0, and yes, so the effect is to sign 0 first to k, and then to j, and finally to I. So that's what you have to remember. Okay, so again, watch out for unexpected na results in chained assignments as a result of type conversion. So, for example, we have again an integer I and a float na f. So, I is assigned the value 30. We know that 33.3f is a decimal na value or a float na value, but your I is an integer. So when we have assigned 33.3f to I, the value will now be 33. Okay? Now, this 33 will be assigned to your float variable f. So, the value of f now is not 33 but 33.0, but not 33.3 as you might think because of type na conversions. Okay, so you have to be careful regarding this kind of issues. Okay. So now what about for the L values? So the assignment operator requires an L value as its left na operand. So an L value represents an object stored in computer memory and not as a constant or a result of a computation. So variables are examples of, or not an example, but actually L values, okay? So expressions such as 10 or 2 times I is not an L value, okay? So here are some examples. So I is a valid na I na L value, but I plus 1, which is an in which you have an operator here plus is not a valid na L value. Okay. And what else? Again, an L value can have a value assigned to them, and it's placed on the left hand side of an equal na sign. And example, given the declaration int I, so I is an L value, so it's legal to say I equals 1, but I plus 1 is not an L value because you cannot assign a value to I plus 1, and I plus 1 is just a computed na value. So 1 is also not an L value because you cannot assign a value to a constant. So the compiler will detect errors of this nature, and therefore you will get an error in a message. So next topic is about compound assignment na operators. So when we are performing assignments, there are some cases when we use the old value of a variable to compute its new value. So it's very common in C in a program. So C's compound na statement operators allow us to shorten this statement. So these compound operators are plus equals, minus equals, times equals, divide equals, percent equals. So for instance, we have, we want to compute for I plus 2 and store it to I. So we are using the old value of I and store it in also I. So basically replacing the value of I. So in C, it allows us to shorten to only I plus equals or 2. So here's the formally, we have the A operator equals B, which is equivalent to A equals A operator B. So here are other examples. So A plus equals B is equivalent to A equals A plus B. So A minus equals B is equivalent to A equals A minus B. So the same for the other operators such as multiplication, division, as well as the dealing with compound assignment operators. There are some things that we must note and remember. So for example, we have I times equals J plus K. So it is not the same as I equals I times J plus K due to operator precedence. So your I times equals J plus K, the one that uses compound assignment, is interpreted as I equals I times parenthesis J plus K. Meanwhile, your I equals I times J plus K is being interpreted as I equals grouped I times J plus K, because the multiplication operator has higher na precedence. So in I, so it's better to again use parenthesis. You have to remember that one in order to avoid ambiguity in your code. So also switching characters may yield expressions unacceptable to the compiler, but that doesn't have uh, the intended meaning. For example, I plus equals to j is not the same as I equals plus j. So your I plus equals j, the one that uses the compound assignment na operator, is interpreted as I equals I plus j. Meanwhile, your I equals plus j is I equals parenthesis plus j. Okay, so we are grouping plus j here. Okay. So the assignment operators have the same properties as the equal operator. So in particular, they are right associative. So your statement I plus equals j plus equals k means I plus equals grouped j plus or equal to k. So we are grouping from the right first. So we are grouping your j plus or equal to k first. So first, let's refresh what you have learned with a few exercises. So we show the output produced by each of the following program fragments. So assuming that your I, your j, and k are integer variables. So for example, we have 4 items. So let's just move to the next slide. Okay, so for the first slide, so we simply had to copy the code fragments earlier and paste it in our CNA program. Okay, so assuming that your I is equal to 5, we are on line 7. So assuming that your I is equal to 5 and your J is equal to 3, so we print a the value of your I divided by j and I percent j, or the remainder of your I and j. So your 5 divided by 3 will be equal to 1. Okay, so we are dealing with integers, so we are truncating the result. So it returns also an integer, which is only 1, and your remainder of I and j is 2. So 5 divided by 3 is 2. So now for line 10, so we have, assuming we have a value of I which is equal to 2 and your j which is equal to 3. So then we want to print the value of I plus 10 and then parenthesis, then percent j or percent j. So we add I plus 10, so that's 2 plus 10, which is equal to 12. And then 12 divided by your j, which is equal to 3, which is equal to 4. So since we are computing for the remainder, 12 divided by 4 has results to 4, and the remainder is 0. That's why we have the 0 here. And then next we have I equals to 7, and then we are on line 13 now, and then your j is equal to k, and 8 in your k is equal to 9. So we are computing for I plus 10, parenthesis, then percent k divided by j. So since your I plus 10 is in a parenthesis, so it will have the highest na precedence. So your I plus 10 is, your I is 7, so 7 plus 17. Now, what has the higher precedence? Percent or the division? So we know that your remainder operator and your division operator have the same na precedence. So we are now following the associativity rule. So we know that your remainder and your division operators are left associative. So we will be grouping from left to right. So we will group the result of this first, the I plus 10, then remainder k. Then you group that one, or you evaluate that one. So we have 17 divided by your 9. So that's 17 divided by 9. That's 1. And then the remainder will be 9 also. 8. And then you divide it by j, which is equal to you have your 9 here divided by j, which is equal to 8. So 9 divided by 8 is equal to 1. Okay, so that's why you have your 1 here. And then in line 16, you have, assuming we have a value of I equals 1, j equals 2, and k equals 3. So your I plus 5, which are grouped in parentheses, and your j plus 2, which are grouped in parentheses, will have the highest precedence. So you evaluate this first. Your I plus 5 then is equal to 6, because your I is equal to, has a value of 1. And meanwhile your j is 2, so 2 plus 2 is 4. So now for following your associativity rules, which groups from left to right, so we have to perform 6 remainder 4 divided by 3. So 6 remainder 4, we have 2. 2 divided by your k, which is 3, will be equal to 0, since we are dealing with integers. Now, we show the output produced by each of the following program fragments. Assume that I, j, and k are integer variables. Okay, what about this one? So why don't you study this on your own, or if you cannot understand, just message me so we can proceed to the next set of examples. Okay. So now let's move on to your increment and your decrement operators. So we are so close. Okay, so for the increment and decrement operators, okay, so two of the most common operations in a variable are incrementing and as well as decrementing, which are simply operations for adding 1 and subtracting 1 to a variable. So for example, we have I equals I plus 1 and j equals j plus 1. So essentially we are just adding 1 to your variable I, and then stores it to I, so the new as its new value, and then we are just subtracting 1 to the old value of j. Okay, so we can perform or convert this using compound operator. So it allows us to shorten your initial na codes I equals I plus 1 into just I plus or equals to 1. But in C, it allows us to increment and decrement variables with a more shortened na version using the plus plus and the minus minus na operators. Okay, so at first glance, the increment and decrement operators are simplicity itself. Plus plus adds 1 to its operand, whereas your minus minus subtracts 1. So this simplicity can be misleading. So the increment and your decrement operators can actually be tricky to use. So your minus minus and plus plus have side effects, and they modify the value of your operand. So we have prefix and the postfix na increment and decrement operator. So as you notice here, you can have the plus plus after your variable, or you have the plus plus before your I. So the I plus plus is your postfix, and your plus plus I is your prefix. So we will discuss this one. So your increment operators, essentially it is just used to increase the value of your variable by 1. And your decrement operators, I plus plus and your minus minus I, are used to decrease the value of the variable by 1. So unary operators, that is, they operate on only one operand. Okay, so now what about them? So what's the difference between your pre-decrement, pre-increment with the post and the post-decrement and post-increment? So in your pre-decrement or pre-increment, from the word pre itself, meaning before, so the operator comes before the value. So the value of your expression is incremented or decremented na values. For example, you have you have an integer I with a value of 12, and then you have an integer j, and then your j, the new value of your j is now your plus plus I. So now the value, since as I have mentioned, there are side effects. Okay, so your this operator changes the value of the operand that it is applied to. So your I is now equal to 13, and your j as well is 13. So essentially your I will be incremented and j will contain the incremented na I. So now they are both 13. So what about your post decrement or your post na increment, or your I plus plus and your I minus minus? So in here, the value of the expression is the original value before it was modified. So let's have an example. So assuming we have an integer I with assigned with a value of 12, and then we also have an integer j, and your j is equal to I plus plus. Okay, so when we print this out, the final value of I is 13. So we are changing the value of I, but j is equal to 12. So what happens is your j will contain I first. So initially your I is equal to 12. So the 12 will be contained by j, and then later your I will be incremented. So your I plus plus, after I plus plus, your I is now 13. Okay, so let's have an example. So assuming we have integers a and b with values 10 and 100, and so we are in line 5, and we also have float variables c and d with values 10.5 and 100.5 respectively. So we have in line 8, we would like to print the value of plus plus a. In line 9, we want to print the value of minus minus b. In line 10, the plus plus c, and in line 11, the minus minus d. So what are we testing here? We are testing for the pre-increment and also the pre-decrement. Okay, so now what will be the result, or what will be printed for line 8? The plus plus I. Yes, it is 11 because it changes the value of your operand, which is A. So now your A is 11. Now, your minus minus B is now 99. We are subtracting 1. Your plus plus C is 10.5. We have added plus plus C, so we are adding 1. So it's now 11.5. And for D, we have minus minus D. So we are subtracting 1. Now it's 99.5,000. So we have declared it as a float. That's why we have an extra zeros here. So let's have a bit more examples. Okay, so let's try printing, showing the output produced by each of the following program fragments. So assuming that your I, J, and your K are integer variables. So let's dissect it one by one. So first, we have declared your variables I, J, and K in line 5. Now in line 7, assuming we have assigned a value of 1 to your I, and in our expression, we would like, in line 8, we would like to print I minus 1. So since we are the I++, we are incrementing. But then in here, we do not change the value of I first. So it is still, the value is unmodified in here first. So it will be still 1. So 1 minus 1 is 0. But when we print 0, so when we print I in the line 9, the value has already been incremented to 1. So that's why it is 2. Remember that we have applied plus plus here. Okay, so what now for line 11, assuming we have I equals 10 and your J is equal to 5. So we would like to evaluate the expression I++ minus plus plus J. So we have the I++, we again the result of the I++ here will be unmodified. So we still have 10 minus plus plus J, but then the J, for the plus plus J, the value of the J will already be modified. So we have 10 minus plus plus J, which is 6. So 10 minus 6, it will be 4. That's why we have the 4 here on the third line in the output. But when we print your I and the J here, so we have previously incremented 1 to your I++. So the value of I is now 11 and the value of J is 6. So isipin nyo na lang na pag nag-plus-plus agad kayo, immediately match-change agad yung value ng J or ng variable. But pag later pa kayo, later or nag-post increment or post decrement pa kayo, sa next call nyo pa ng variable, dun pa lang match-change yung value niya. Okay? So, yeah. So what about for line 15? So assuming we have I equals 7 and your J is equal to 8. Okay, so we want to evaluate the expression. We are in line 16 now. You have I++ minus minus J. So we have the I++. So the value here of I is 7. So it will still be 7 minus the minus J, immediately changing the value of your J, which is 8 to 7. So we have 7 and a 7, that will give us 0. That's why we have 0 here after 11 and 6. And then when we print the value of I plus J, so now your I is already changed. So it will now be 8. And your minus J is still is now 7. So that's why we have 8 and 7. Now for the line 19, so assuming we have I equals 3, J equals 4, and K equals 5. So we have I++ minus j plus 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 minus minus k. So your I plus plus, still your I will be still 3 minus j plus plus, which is 4. So 3 minus 4, that will be negative 1 plus negative 1 plus minus minus k. So negative 1 plus negative 1 plus 4. So that will be 3. So that's why we have 3 here, the second to the last. And then when we print the value of I and j and k, your I is now 4 and your j will now be equal to 5 and your k is now 4 since we have decremented 1 from your k. Okay, so this is just a summary of the operators that we have discussed in order of precedence. So the first on the list is your postfix, na increment and decrement, followed by your increment, decrement, na prefix and uh, and then you have your unary plus and unary minus. So as you can see, your unary na operators are on top of the list, followed by your binary na operators. Okay, and now we have, let's move on to the next na operator, the relational operators. Okay, so several of C statements need conditions or comparing values. We need to compare values. It's always present in every programming problem. So for example, we would like to test if a value of a number is greater than the other. We can do this by using relational operators that are being provided by C. So they are the binary operators that takes two operands. Okay, so some of the examples we have greater than or equal, equal, less than equal, 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 and then the not equal, as you can see here. Okay, so they are binary operators, again, that takes two operands, and also they yield an integer. So with a value of 1 if it is true, and 0 if it is false. So for example, the value of 10 less than 11 is true, so it returns a 1. And the value of 11 less than 10 is false, so it returns a 0. So in C, there is no true or false na value. It's always 0 or not 0. Okay, so yep. And relational operators, again, can be used to compare integers and floating point numbers with operands of mixed types allowed. So thus, when we compare, for example, 1 is less than 2.5, it has a value of 1, since we know that your 1 is less than 2.5, and 5.6 less than 4 is 0, because your 5.6 is greater than your 4. So again, you can compare integers and floating point numbers in mixed types. So since they yield a value, you can use them in an equation. So for example, this expression, I less than j times 38. So we embed this relational expression I less than j to your assignment na expression. But it is weird and also not recommended, as it's making your program hard to read. So alternatively, you can write it this way. We assign 38 to k only if your I is less than j. So again, you please try to avoid embedding relational na expressions in your assignment na operations. Okay, so here's just a summary of the operators. Okay, so just check this later on the slide. So it's self-explanatory. Okay, so your equals equals, it simply checks if your two numbers were equals, your greater than, checks if your 5 is, if your certain number is greater than another number, same your less than or equals or your compound operators checks if a certain number is greater than or equal to. Okay, so yes. Now, what about for the precedence of the relational operators? So there are some things that we have to note. So your arithmetic operators have higher priority than your relational operators, meaning that if arithmetic expressions are present on two sides of a relational operator, then the arithmetic expressions will be calculated first and then the result will be compared. So for example, we have I is less than j plus 3. So it is not being interpreted as I is less than j, then you add it to 3. Instead, due to the precedence, we evaluate j plus 3 first, and then we compare it to I. Again, your arithmetic operators have higher precedence or higher priority than your relational operators. Okay? The relational operators are also left associative. So for example, we have the expression I is less than j and less than k. So you might think that we are comparing, first comparing that j is greater than I, and then j is less than k. But this is not the case. The expression does not test whether j lies between I and k. So this one is legal in C, but again, it doesn't have the meaning that you might expect. Since the less than operator is left associative, the expression is evaluated as I is less than j, first grouping your I less than j and then comparing it to k. So next, we can also test if two values are equal. So we use the equality operators. We use the equality operators equals equals and not equals for this purpose. So the equals equals is simply test whether two values or two operands are equals. It's very self-explanatory. And then your not equals is simply testing whether your two operands are not equal. So, but there are some things that you have to note and also shouldn't confuse yourself with. So you don't count on testing floating point types with double equals. Okay, so why? Your real numbers on the computer differ by an insignificant amount, and your equals tests for exactly equal. Okay, and like your relational operators, your equality operators are also left associative and produces either 0 or for false or 1 for true as the result. So however, the equality operators have lower precedence than relational operators. For example, we have this I is less than j equals j is less than k. So it is equivalent to grouping or testing first whether I is less than j and also whether your j is less than k before testing whether the two are equivalent. So which is true if I is less than j and j is less than k are both true or false. Okay, so again, don't you confuse yourself with equals equals with only the single equals. Okay, so if I is equal to 0 is not equivalent to if I equals 0. So the above code is legal but doesn't do what you want. Why? Because your I equals 0 is an assignment na operation. So basically, we are setting the value of I to 0 while your I equals 0 compares whether the value of I is equal to 0. So its resulting value is either 1 or 0. Okay, so why don't you study this na lang? So, but I'll just give a brief na example. Okay, so assuming we have variables a equals 5, b equals 5, and c equals 10. Okay, so your on line 7, we are testing whether a is equal to b. So your A and B both have a value of 5. So since they are equal, it results to the result of A equals B is equal to A equals B is equal to 1. Okay, now let's move to line 9. In line 9, we are testing whether A is greater than B. Your A and B again are equal or they have the same value of 5. So we know that they are equal, so and A is not greater than B, so the result is 0. Now what about for line 13? For line 13, we are testing whether A is not equal to B. So A is equal to B, so this will result to 0. Okay. Okay, so let's have an example, but I'll just go over this very quickly and you can study this on your own. Okay, so assuming we have this block of code and then we want to evaluate the value of these several expressions that we have listed in the previous slide. Okay, so first let us declare our variables I, j, and k. So now for line 7, we set a value of 2 to I and j to 3. So in our line 8, the expression is k is equal to I times j equals 6. So which one has a higher precedence? So as we have discussed earlier, your arithmetic na operators have higher precedence than your equality na operators. So what we are going to do is evaluate your I times j first, which is basically equal to 6. Okay, and now now after evaluating I times j, we can now compare it to 6. Okay, remember that your equality na operator double equals has higher precedence than your assignment operator. So your I times j is equal to 6 compared with 6, and we know that they are equal. Of course, that's very basic. So 6 equals 6. The result, since it is true, the result of your k will be 1. That's why the result of A here is also 1. Now, for line 11. So for line 11, we have I is equal to 5, j is equal to 10, and your k is equal to 1. Okay, so we want to evaluate the expression k is greater than I and you're less than j. So as we have said earlier, we do not test whether your I is greater than k or less than j. Rather, due to associativity rules, we group or evaluate your k is greater than I first. Is your k greater than I? Yeah, k has a value of 1 and your I has 5. So 1 is greater than 5, that is false, so that is true, or that is false, so that is 0. 0 is less than j, which is equal to 10, which is true, so that's why we have the b, which is equal to 1. And now, what about for line 14? So assuming we have I is equal to 3, j is equal to 2, and your k is equal to 1. So we want to test for this expression in line 15 na ha. So we have I is less than j, double equals j is less than k. Your relational na operators, I is less than j, and your j and greater than k have higher precedence than the equality. So we first evaluate your I is less than j first. So is your I less than j? So 3 less than 2, so that is false, which is 0. And your j is less than k. Is your j less than k? So that is 2 less than 1, that is also 0. So 0 double equals 0, which is I less than j 0, double equals j less than k, which is 0. So we have 0. We are testing whether the two zeros are equal, which is, of course, they are equal, so that will return a 1. So that's why we have a 1 in letter C here. So, and then for line 17, we are assuming a value of I equals 3, your j equals 4, and your k is equal to 5. So, your arithmetic na operators have higher na precedence than your relational relational operators. So we will first evaluate I %j plus 1 before comparing it to k. But your within your sub-expression, I remainder j plus I, so your remainder has higher na precedence, so we evaluate this one first. I remainder j, which will be 3 divided by your 4. Okay, so we are nearing the end. So our next is the logical na operators. Okay, so what is the logical operators for? So what if we need to combine more than one relational na expression? More complicated na logical expressions can be built from simpler ones by using logical na operators, your and, your or, and not. So we will discuss in the next slides on how you can use these three na operators. So the not na operator is unary because it only applies to one operand, while your and your or are not, so they require two operands. And these operators can be used when more than one conditions are to be tested, and based on the results have to be made. So for example, we want to test whether A is less than 18, or if A is greater than 60. Okay, so an expression it's an expression that we can use to combine two or more relational expressions. So here's how you can use your logical na operators. For the and, the logical na and, so it returns a true when both conditions are false. So for example, if your x is greater than 5 and your y is less than 5, that will return a 1 if indeed your x is greater than 5 and your y is less than 5. And then your logical or will return a true when at least one of the condition is true. So you can refer to this table, assuming your 0 is false and your 0 is false and your true is 1. Okay, so it will only return true when at least one is true. And then for the not table, so it reverses the state of the operand. So if it is true, logical not will make it false. Okay, so here's just a summary of the logical operators precedence. So again, the highest na precedence, the operator with the highest precedence will be the unary operator, which not is an example, followed by your relational operators, your equality, and your and your logical na or. Okay, so your relational na operators have the lowest na precedence. Okay, so just you can study this on your own, I think. So let's just have a quick overview dito. Okay, so assuming we have variables a, b, and c and result, and your a, b, c have values 5, 5, and 10. Okay, for the line 8, we are evaluating this expression where we first check whether a and b is equal, and whether c is greater than b. So we know that your and has the lowest na precedence, so we first evaluate whether a equals b. So is a equals b? Yes, indeed, because your a and b is 5. And then is c greater than b? Yes, so they are both true. So since in your and, logical na and, it will return 1 or a true only if both of your operands evaluate to true. So that's why your result here is 1. Now for the line 11. The line 11, so we evaluate whether a is equal to b and whether your c is less than b. Similarly, your a is equal to b because they both have a value of 5. But your c is not less than to b because your c is 10 and your b is 5. So this will return a false. So your the first na operand a equals b is true, but since your second operand is false, your result will be equal to 0. Okay, again, in your logical and, we want that your two operands are true. And for line 14, we are using the logical na or. So we first check for the equality of a and b, and then we evaluate whether c is less than b. In logical or, again, we want that in order for it to return a true or a 1, so at least one of the operands is true. It will already return a 1 or a true. So we know that our a is equal to b, so this is already true. So whether your c is less than b or whether c is greater than b, since we already have a true dito, so this will return a 1. But then, in your line 17, we are checking whether a is not equal to b and whether c is less than b. Your a is not equal to b, which is false because they both have a value of 5. And we know that your c is not less than b. Okay, so they are both false. So both false. So in your logical false, so magiging false lang siya if both are false. That's why the result in your line 17 will be 0. Okay, so now for line 20, we are we are using the not variable. But we must evaluate the expression within your parenthesis first. So your a is not equal to b. Is it correct? It is 0 or false because your a is equal to b. So your not false or your not 0 will be reversed because we are using the not operator. So that's why the result here will be 1. Okay, so what about for line 23? So we are checking first for the equality of A equals B. So, and then we must evaluate the expression within the parentheses. So yes, your A is equal to B, so this will return a true, so which is 1. Then we will use the not operator. Since we are reversing it, so not 1 or not true, so this will return a false or a 0. Okay, next. So you can just study this on your own. So let's quickly go over this example. So in line 5, we are declaring variables I, j, and k. So in line 7, we are assigning values 10 and 5 to variables I and j. Okay, so on line 8, we would like to evaluate the expression I, not I is less than j. So we first evaluate not I. So not I is not 10, so meaning you are, that will be 0. So your 0 is less than 5 or j equals 5. That is true, so that will give us a 1. Now for line 10, your I is equal to 2 and your j is equal to 1. So we would like to evaluate not I and plus not j in your line 11. So in your not I, so that means not 2. So not 2, that will give us a 0, and not 0 will give us a 1. So 1 plus your not j, which will give us not 1 equals 0. So 1 plus 0, that will give us a 1 for line 11. And then for line 13, we are assigning 5, 0, and negative 5 to your variables I, j, and k. So we would like to evaluate the expression I and j or k. So your and has a higher precedence than your or. So we evaluate I and j first. So that is 5 and 0. So your since in and we require that two operands must be true in order for it to return a true or a 1. So having a 0 or a false in this expression and the expression will result to having a false or a 0 in the result. So that will be 0. So 0 or k equals 5. So that will give us negative 5 pala. So that will give us a 1. So and then for line 16, so we have variables I, j, k assigned to values 1, 2, and 3. So we would like to evaluate the expression I is less than j or k. So your relational operator less than has a higher precedence than your or na operator. So or your logical na operators like or. So we evaluate I is less than j first. So is your I less than j? Yes, because your 1 is less than 2, which is true. So since we already have a true in the expression, that will automatically result us to having a 1 or a true na result. We don't even have to evaluate the k already since we already have a true. So this will automatically result to true. Remember that in your or, we only need one true na operand for the sub-expression to result to true or 1. Operators or ternary na operators. Lastly, we have the conditional operators, which is a ternary operator that works on 3 operands. So we have a conditional expression and also 2 na expression. So the conditional na expression is evaluated first, your conditional expression, and this expression evaluates to 1 if it's true and evaluates to 0 if it's also false. So if your conditional expression is true, your expression 1 is evaluated, and If conditional expression is false, your expression 2 is evaluated. So for example, we have um, let's say variables ijk declared, and then we set I to 1 and your j equals 2. So in our conditional expression k in line 9, our conditional expression is I is greater than j. So if your I is greater than j, it will return I. If your I is not greater than j, it will return j. Okay, so in here, let's check first, is your I greater than j? False. So since it is false, it will the value of the k will be equal to j. And since your j is equal to 2, your k is now 2. Now, for line 12, our expression is first checking whether I is greater than or equal to 0. And so if your I is equal to greater than or equal to 0, it will return it will return this expression. It will return I, and then else it will return 0. So let's check. So is your I greater than or equal to 0? Yes, indeed, because your I is greater than 1. So your it will evaluate this I, the I. So your I is 1. So now your 1, the result of this will be added to j, which is equal to 2. So 1 plus 2 is equal to 3. So the value of your k is now 3. So notice that I had a mistake on while I was trying to explain the line 12. Why? Because the program is not that readable, and I had a bit of confusion. Ay, bakit bigla na lang may parenthesis dito at bigla na lang may plus j? So, this is not a good idea. So, while your conditional expressions tend to make your programs shorter, it also makes the programs harder to understand. So, it's better to avoid them. Okay. So let's have a little bit of an exercise. So what does the following statement printf print if I has the value of 17? So what does it print if I has the value of negative 17? So this is your conditional expression. So this is supposed to be a question mark, not a slash. Okay, so if your I is greater than or equal to 0, it will return an I, otherwise it will return negative I. So let's check what if the value of I varies. So first, we would like to know what would the result of this expression if your I has the value 17. So your 17 or your I is greater than or equal to 0, and it is true because 17 is greater than 0, so it will evaluate I, this first na expression. So it will print 17. Now, what if your I is negative 17? So since your negative 17 is less than 0, it will evaluate negative I. So the negative of the negative I, the negative of negative 17 is 17. That's why it also prints 17. So that's all. So I will be uploading the sample codes discussed during the lecture in GitHub, and after I'm done uploading the slides. And so what you can do is try to run it in your own computers in order to get familiarized with the way it works. Okay, so remember that you can only get proficient at
programming or get better at what you are doing if you are doing it more. You can always learn by doing so. Try to sit down and practice, copy the codes, and run it in your own device. And do not wait for 1 day or 2 days before the exam before you examine the materials that are being given to you. Okay, so that's all. And thank you for listening. And these are the references, the main references that I have followed. So if you want to have an in-depth understanding of the lessons, and you can always refer to the references that I have specified here. And also, if you have any questions regarding the slides, kindly email me to abiambita@gmail.com with the subject ComSci 21, bracket CMSC 21, and then consultation, and then list down your question, refer, and also list down the slides or in which you have the specific slides that you have that you are confused with. Okay, so please do so, and so I can help you understand, and then I can help you also I can help you with understand what we are doing here. Okay, so thank you for listening, and I hope you did reach the end of these slides. So let me know if you have questions again. So thank you. See you some other time. Okay.